Okay, so I'm going to make a few videos on angles and parallel lines and angles in polygons. So this first video is just going to be covering angles and parallel lines, and we're going to start off fairly basic, as you'd expect. I'm going to start off with this question here, but we're going to look at these three rules and how they relate to these questions. And we'll probably look at a couple of examples here. Now, you'll notice that I've highlighted them here. Let's have a look at these three rules. We've got the key words for these different rules as well. If I were to get two parallel lines, which I've highlighted the pairs of parallel lines in yellow, and then if I were to take a third line and go through those two parallel lines, which I've highlighted in green and in the example question there, then we can say a few things about the angles that would be made here. I think what I'll do is do it again and highlight of all the angles that we can look at, and then we'll look at them in turn. Okay, so I've made two different ones here, and the reason is so as I could get the green line to go sloping in different directions and show you that it doesn't make any difference what direction. A lot of people get confused about identifying some of the angles, especially the alternate angle. So we'll look at this one then, and we'll try to see if we can apply the rules to these situations. So with the corresponding angles, we're saying these two angles that they've labelled there are equal to each other. So if we look at this one on the right, it looks most similar to what they've got there, and we would be able to say that this angle and this angle are identical to each other. So how can we see that these two are corresponding? It looks like they're corresponding from how they've done it. I'll use a third highlighter now to show the shape that they've done. They've called F angles, and it's because it can look like an F. If we do that, then we're seeing these angles in the corners of the F shape, F letter. Now, it's it's productive to a degree, it's helpful to a degree to think about it in that way, but not completely helpful. So I'll show you why it's not helpful in a moment. But so let's unhighlight that, and we can say that next to that C is equal to G. So we can looking at this, C is equal to G. Now the same is true of this one. Okay, even though it looks a little bit different, it's still true that this G is equal to that C. I've labelled it in the same way. So according to both of these diagrams, C is equal to G. In fact, I would say C and G are corresponding angles. Now, if we look a bit more closely, what can we say about these two angles? Let's highlight C and G again for a moment. So they are both the same side of the green line, aren't they? One is between the two parallel lines, and one is on the outside of the parallel lines. So that's a kind of a way of realizing that we're looking at corresponding angles. So you might want to now pause the video and see if you can find the other pairs of parallel lines. The other pairs of corresponding angles in amongst here. Okay, so C and G are one pair of corresponding angles in the parallel lines. And can you come up with the other pairs? So if you want to pause the video now, and when you unpause it, I will reveal the answer. So, okay. So hopefully you said, well, we already got C is equal to G. You can also say that F is equal to B. So F and B are corresponding, okay? You can say H and D are corresponding. I'll put the other one over here. We can say E and A are corresponding. And that's all of them, isn't it? I think. Yeah, I think I've got them all there. So now let's look at the next one. We've got supplementary or co-interior angles, and this is the odd one out in that we're not saying the angles are equal to each other. We're saying that these two angles add up to 180. I'm going to actually make these purple because I've color coded the rules as well. So I'll make my next color blue. So maybe you can have a go at all of the angles that you think are supplementary or co-interior. So you want to pause the video now and try to find all the pairs. And I'm now going to reveal one, and you can always pause after each one and then see if you can do the rest yourself. But I'll do one of them then. If we look at them in detail here, we've got they are both in between the parallel lines and both the same side as the parallel lines. So we've got C and F. C plus F is equal to 180 degrees. And the other pair is D and E. So D plus E is equal to 180 degrees. Okay. Right, so there's not as many in that case because they're the ones that are in between the two parallel lines. So now let's switch to green, and we're looking at alternate angles. So alternate angles are but also between the two parallel lines like co-interior, but this one is the odd one out in that it's one side of the green line and one is the other side of the green line. Now these are often called Z shape, but like all these, for example, if we go back to co-interior for a moment, D and E, that wouldn't form a C shape, it would be a backwards C. So although this said Z, well that's a backwards Z already. They could be backward, and also they could, especially the Z shape, can look a bit weird. So again, pause the video, see if you can identify all the Z angles or all the alternate angles. Okay, and I would say the first one you might notice is E and C because they're the ones that are most similar to that. So E, and this time is equal. E is equal to C. Okay, and the other one, which the other one is D is equal to F. D is equal to F. Okay, so if we look at on this example, like if we're talking about E and C, then that would be this shape there, which looks a bit more like that one there, right? But if we look at it on the other one, it looks like that, which looks a bit weirder because it's like slanted. We like these angles here are acute angles, and these ones are obtuse angles, so it kind of looks a bit different, but it's still the same. I want you to see if you can notice how these are the same, not to be put off what direction the green line is facing. Now, the other thing that we want to notice about this is that, so if I were to, can I copy all of this? Okay, can I copy? Let's try that again. Okay, so now what I'm going to do, I'm just going to give values to all these, and we're going to see how this works out. So let's say that this angle here, okay, try again. This angle here, I think I want black actually, is, I'm going to say 45 degrees. Why not? 45 degrees. And let's use the corresponding angles first. Well, if that's 45 degrees, then that's 45 degrees. Okay. Now let's go on to the co-interior angles. Well, that would mean that this angle here is, 45, we're saying 45 plus this angle is equal to 180. So therefore 180 minus this angle will equal to whatever that angle is. So that would be 135 degrees. Okay, so basically what I did is we did 180 degrees minus 45 degrees. And the reason why I did that is because this mystery angle here, which we can see would be C, I suppose. We could call it C. We could say that C plus 45 degrees is equal to 180 degrees. So I rearranged the formula. I subtracted 45 from both sides, and I got C is equal to 180 minus 45 degrees. Okay, so I've got this one now. Now I can actually go back to a corresponding angles, and I can see that this angle is corresponding to that one, so that must be also 135 degrees. Okay, so I've done the corresponding and the co-interior, which are both the same side of the green line. So now we can go over to the alternate angles. So I can see that this angle here, which before was F, is equal to this one here, right? So F is equal to D. So this is like my D angle, right? So that means that must be 45 degrees. And now I can go back to my corresponding angle. I can see that that's corresponding to this one, which means that's 45 degrees. And we can, what else can we do? We can go back to an alternate angle now, and we can say that that is alternate to this one, so that must be 135 degrees. And this is corresponding to this one. We could use a variety of different rules now, but maybe we can use let's use the corresponding is the only angle where we can, only rule where we can look at the ones that are outside the parallel lines. The other two are between the parallel lines. So this one and this one is 135 degrees. Now, the main reason I wanted to do that is to show you that if in all these angles, using all these different rules, there are eight angles, but there are only two different values. With parallel lines, in this situation, you only ever have a small angle and a large angle, and the two angles add up to 180. And on top of that, we can see that we could have applied other rules here. So we could have applied angles on a straight line, and we would have also have got some of these angles. We would have also been able to work them out. You'll also notice that opposite angles tend to be called vertically opposite angles. So if we get any two lines, then if we cut any two lines, we intersect any two lines, then this angle is always equal to this angle, and this angle is always equal to this angle. So angles on a straight line and angles and vertically opposite angles are not to do with parallel lines, but you can still apply those rules as well to be able to solve the problems. Okay, so that's the introduction, and the next video we'll look at some example questions.